Hey, hi guys, good morning. Okay, so today we will quickly revise the topics, whatever we have covered, the important topics. And tomorrow I will walk you through uh, some use cases around CNN and LSTM. Okay, and then from Saturday, Vikrant will take a class on Spark. Okay, so And today, guys, I want this session to be more interactive because I want to understand like what is your understanding so far on all these topics. Okay. So feel free to ask any questions if you have, or if I'm asking any questions, so please respond to that. Okay. All right. So firstly, can anybody tell me what is the difference between supervised learning and unsupervised learning? And you can consider these questions as interview questions, guys. So if you don't respond, then no point of today's class, guys, because I want this as a revision class and I want to understand what's your knowledge so far on these topics. So anybody, and see, don't shy away. Okay, it's okay. I just want you to try or attempt whatever you know. Okay, so I can correct you, I can guide you, and in that way, it would be helpful for you to face the interviews. Okay, so tell me what is the difference between supervised learning and unsupervised learning? Harishree, Shraddha. Yeah.
In supervised learning, we have defined input and output,
Mm-hmm.
whereas in unsupervised learning, we do not have any defined output. So it doesn't have any column to predict something like that.
Okay, perfect. That's a very good answer. Okay, so following question could be where we can use unsupervised learning. What for we use unsupervised learning? Harishi, try. Okay, so you are almost there. Okay, so I think you can answer. So tell me where do we use unsupervised learning? Just recall all those unsupervised learning algorithms, whatever we have discussed, and just summarize that and tell and frame your answer.
Temperature prediction.
Sorry,
Te-
unsupervised learning. I'm saying. What all are unsupervised learning algorithms? Can you name those algorithms?
Linear regression, logistic regression.
Unsupervised learning, unsupervised learning means where you do not have output variable, right? You only mentioned. So in the linear regression, the logistic regression, we do require output variable. So
Yes.
unsupervised learning algorithms are clustering algorithms, recommendation system algorithms, and we discussed about PCA, dimensionality reduction algorithms. So all these comes under unsupervised learning. If somebody asks you where do you use unsupervised learning, firstly you say that wherever uh, we we encounter or we do not get a label data, okay, there we can go with an unsupervised learning. So for and with unsupervised learning algorithms, we can perform clustering, which can group the data into different homogeneous groups, and further by evaluation, we can categorize that data. Uh, and then you can talk about recommendation system. So for example, if we have a data and we want to find out the similarity between the patterns, and then based on that, if we have to build some recommendation system, there also we can use some unsupervised learning techniques like collaborative filtering, like content-based filtering. So And then even for dimensionality reduction, we use unsupervised learning techniques. So that's how you should answer if somebody is asking about unsupervised learning. Okay, so now let's talk about KNN. Can anybody quickly tell me like how this KNN algorithm works? KNN. Okay.
So yeah, it looks at the nearest neighbor which has similar attributes,
Okay.
similar features.
Okay. So see, I hope that you know the answer, you know about the algorithm, but the way you have explained is not, it does not look complete. Okay. And even everyone will agree. So how you want to say, how you want to answer this particular question is as if the other person has no idea about this particular algorithm. You have to frame your answer in that way. And these are like tips and tricks I'm telling. Okay, so if you just give one single liner response or something like that, it first of all it doesn't sound good. Okay, it may reflect that you have you know you're just answering only that part which you are aware of. Okay, and rest of the things you kind of you are skipping, and or you probably it shows the impression that you don't know the complete understanding about that algorithm. So these are the points, and note it down. Okay, firstly, you have to mention in which family of machine learning this particular algorithm belongs. Okay, so firstly, you have to say that it is a supervised learning technique. Then you have to mention that for what all purposes this particular algorithm would be utilized or used. So you can say that it can be used for regression as well as classification, but mostly it is used for classification problem. Then after this, you have to mention at a high level on what kind of approach this particular algorithm takes, to solve a problem or to get trained. So here you talk about that similarity. It assumes a similarity between the new case data and available case and put the new case in the category that is most similar to the available categories. Or you can frame in whatever your language, okay, wherever you are comfortable. So how you have to frame your answer is first you have to tell from which family it belongs, whether it is a supervised or unsupervised learning technique, and then you have to mention for what all purposes this particular algorithm can be used, and then you have to mention about how it works. Okay, so you can say that it identifies the nearest neighbor by using Euclidean distance or some other distance measure, and based on the nearest neighbors, it classifies that new data or the new observation. Okay. So, and after that, if there are any following questions like if the interviewer wants to dig deep, like how you optimize the model, what are the different hyperparameters you can tune for this model. So that's something, okay, you have to answer later if the interviewer is asking. You need not to tell all those details at, in the beginning. At a high level, you have to just mention how it works and what is the purpose of this particular algorithm. Okay. So, what are the different hyperparameters do we have for this particular algorithm? How can we fine tune this particular algorithm? Just think about it. You know that for majorly all the machine learning algorithms, there are hyperparameters which you can use or which you can tune to improve the accuracy of the model. So for this KNN, what is that hyperparameter?
K value.
K value. And how would you decide the the optimal K value? What is this K value, first of all?
The number of nearest neighbors to be
Exactly.
considered.
Exactly. So how you will decide the optimal value of K? Can we take a lower value of K?
No.
What kind of challenges we may face if we go with a low value of K?
We may not be able to get all the categories inside that, all
Mm-hmm.
the unique categories inside that.
Okay. Any other thoughts, guys? Tej, what are your thoughts on this? Again?
I think the K value has to be odd number, and if I'm not wrong, I think
Yes, yes, yes.
it
It
has to
has
be
to be odd.
optimal value was 5, I believe. 3 or 5. 5 you gave, I believe.
Okay. So
5, I believe, yeah.
I don't know whether I've covered this particular point or not. See, if you have n number of observations, typically in some of the books you will find that square root of n could be the optimal value of k or closer to square root of n. If you have 100 observations in your data set, then somewhere close to 10 could be optimal k value. So there is no thumb rule as such like the 5 or a 6 could be the right number. What you have to do is you have to iterate, okay, multiple times by using different k values, and then you have to evaluate the model and check for which k value you are getting better results. Okay, but to start with, this could be your starting point, like any number closer to 10, like for example 9 or 11 or 13. So you can try that, or else you can even start from you can take certain range like 5 till 21 or 20, okay, and iterate for every k value between 5 to 20. Okay, so the odd number is important, if you are dealing with binary classification, if you have only two classes like 0 and 1, right? And in that case, if you are going with even number, for example 4, so there could be kind of a tie, right? So two observations, if it falls in category 0 and two observations falls in category 1, then it would be difficult for the algorithm to decide which category to choose. Okay, so depending on the problem, depending on the data size, okay, you have to iterate this whole model with different k values, and then you have to check for which k value you are getting a better result. Okay, so if I ask you why it is called as a lazy learning algorithm, so I'll just hide the slide. Why is it called as lazy learning algorithm? And sometimes what happens in the interview is people will not ask you to explain KNN. They will say, okay, explain about a lazy learning algorithm. So then you have to talk about this KNN. Why it is called as lazy learning? Guys, is okay. We are just practicing. Okay, so whatever thoughts coming into your mind, please speak it out.
So because it only takes the nearest neighbors just to consider, that's why it's a lazy. It doesn't look very far off.
See, lazy learning means it is not learning anything, right? There's no learning as such happening. So there is no model which is getting trained. Every time for whatever new data set or new observation on which it has to make the classification or prediction, what it is doing is it is taking that observation and plotting it on the training data set in n-dimensional space and finding out the nearest neighbors, and then based on that it is making the predictions. So basically it is using the training data set always as a reference data, to make the prediction. So there's no learning as such is happening as compared to other algorithms where the algorithms will learn the patterns, everything, and then come up with a trained model. Okay, here that is not happening. So there's a reason it is called as a lazy learning. There is another name to this is instance-based learning. Instance-based learning. So why instance-based learning is because here every time that particular instance it is taking and that particular observation it is taking and is mapping to training data, and based on that it is making the prediction. So So that's the reason it has other names as lazy learning as well as instance-based learning. Okay, so lazy learning, it is called as lazy learner algorithm because it does not learn from the training set immediately. Instead, it stores the data set. What data set, whatever training data set you are giving it to it, it is storing that data set, and then the time of prediction, it performs an action on that data set. Okay, so it just stores the data set, and when it gets a new data, it classifies that data into category that is very much similar to that new data. So now, one more question may come like how it can be used for regression problems. Classification, we understand, okay, from the nearest neighbors, it will find out the majority class, and then it predicts that particular class. But how it can be used for regression? Regression, you know, right? When the output column is the numerical column. And how does that this particular algorithm would work? Simple, guys. It will take the nearest neighbors and whatever values of the output variable uh, is there, for all those nearest neighbors, it will take the mean of those values. So for regression, it takes the mean. For classification, it goes with the mode. Okay, so it's as simple as that. Okay, so so any questions on this, guys? I hope you understand all these things. So I'm just skipping. You know about Euclidean distance. Some question people may ask about Euclidean distance. How does that method works? Okay, and what is the formula about it? Okay, and then it is a step-by-step process. Can you, and people may ask like, can you explain me the step-by-step process of KNN algorithm? So, so you have to mention these steps. It will first select the number of k nearest neighbors, and you have to assign the k nearest neighbors, and then based on the Euclidean distance, it will find out the number of neighbors, and then among those k neighbors, it will find out the number of data points in each category, and then assigns that new data point to the category for which the number of neighbors is maximum. So, for example, so that is basically nothing but the mode. Okay, so this is a very simple algorithm, but we have seen yet effective. So you can try with KNN, and then if KNN is not giving a better result, then you can move ahead with some complex algorithms. Okay, so here somebody would somebody want to explain me what is bias versus variance trade-off? We discussed when we are training the model, this bias and variance, these are the two important factors you need to consider to select the model. So what is this bias versus variance trade-off? Can anybody recall? See, when you're training the model, the errors may occur because of these two factors, either because of bias or because of variance. Okay. And if you remember, there is a plot like this, okay, and you can refer to the notes as well. Okay, so this is how that graph looks like. It is bias, this is variance. Sorry, not this. This is bias, this is variance. And this is the complexity of the model. Okay, so if you are taking a simpler model, in the simpler models, the models are very much prone to biasness. Okay, and this error, if the bias is high for the simpler models, your error may occur because of this bias. If you are going with a high complex models, so that complex models will be highly prone to variance, and the error may increase because of that variance. So you have to take a trade-off somewhere like you have to select the model with a certain amount of complexity, which can reduce the bias and the variance, and because of which the overall error would reduce. So this is something how you can identify such models which is low on bias as well as variance, that you can do it by cross validation. You go and train and test the model multiple times by applying the k-fold cross validation technique, and you can select the model which is kind of consistent and giving you the better results every time. So in that case, your model is not prone to bias or the variance. Okay. So so people may ask like, and this is a very important point for data scientists. So it's not about training any model; it's about coming up with the best model. Okay. So this is the concept what we use to select the best model. Okay. Now coming to the decision trees, anybody can quickly tell me in few sentences what is decision trees? What is this decision tree algorithm? You guys are silent, so I will take it as that you guys are not revising. You are not prepared, guys. Okay. In that way, I cannot help you in terms of where you are lacking, where I need to focus, because you are completely silent. So if you speak, if you attempt to give the answer, I can suggest you where you guys are doing mistake and how you can improve. If you're completely silent, how would I understand? Decision tree we have covered multiple times. That we have also seen in other algorithms also, right? Bagging and boosting. And this is the most common algorithm, people use in the industry. And definitely you will get a question from decision trees. So what are decision trees? How that particular algorithm works?
So basically, decision tree is used for classification, where we might have multiple outputs, so we create a sort of a tree based on that. It could be a binary as well.
Mm-hmm.
When,
Okay.
so I'm forgetting the. I mean, it's been a long
Yeah.
time
So this
since
is
I've not revised actually.
right. So this is where we go wrong. So please, guys, concentrate here. Whatever I'm saying, and please focus on that. I'm not questioning on your knowledge. We believe that we know the answer. We believe that okay, we have that knowledge, and it could be true that you would be knowing that answer. But it's all about how you can impress your interviewer in that 1 minute, okay, of when you are answering that particular question. That has to be impressive. That you have to speak out confidently, you have to speak out, you have to frame the sentences properly. That's where the interviewer will get impressed. Otherwise you will keep losing this opportunity and you will not understand where you are going wrong. So I would suggest, either if you can do this kind of a mock interview together, okay, so that is fine. Otherwise you record yourself, put some questions, okay, just take you know some of the questions, or put just take some random algorithms and try to explain yourself, and then listen to your response, and you only can judge, because you can judge yourself better. Okay, how is it, whether it is impressive or not, and you will understand where you are lacking, whether you are taking too many pauses. Is that your problem, or you're not framing the sentence properly, or overall the answer is not sounding impressive? You will understand. Nobody has to give the feedback. You are so matured, you can understand yourself that whether you're sounding uh, uh, you know good, or you need to improve. And you have all the material with you, guys. You can go through the recording. I have given you the handouts. Yes, plenty of information is available on the internet. Okay, you have to create that crisp, uh, responses or summary on each of the algorithms in your own language. Do not mug. If you mug, what will happen is if you forget any one single word, you cannot you cannot move forward. So never by heart, okay, put it in your own language and try to explain. Understand the concept. If you understand the concept, you can frame the sentence. So that is not a problem. If you don't understand the concept, if you go and by heart or mug, see, if you want to by heart, remember some of the keywords because that will impress the interviewer because, those are very much specific and confined to those particular algorithms. Remember those keywords, but do not mug the entire sentence or paragraph. If you forget anywhere, then you lose out your thoughts and it does not look good. Okay. So for the decision tree, again, it's a supervised learning technique. It is used for both classification and regression, not just classification. Though we have covered only for classification problems, but it can be used for regression also. So how it works on regression is so when the tree is getting formed in any of the node in the terminal node, whatever number of observations are falling, it will take the mean value of all those observations. So that's how uh, it will give the numerical predictions. So just a thumb rule here. Again, I'm giving you a tip. In KNN, we go with the for classification we go with a mode, and for regression we go with a mean. Decision tree also it's the same. In a terminal node, we go with a mode for classification. So which all observations are falling in which of the categories is the majority class, it will go and predict that particular class for that particular observation. If it is a regression problem, so in the terminal node, whatever number of observations are there, it will take the mean of it. Okay, so it's as simple as that. So you just say that for classification, it goes with mode. For regression, it goes with mean. Okay. So now you can take all these points and take the A4 sheet paper. Okay, just put one liner. Okay, clearly those points you remember. One, it is a supervised learning technique. It can be used for classification and regression. Second, it is a tree structured classifier where we have, or it is tree structured algorithm where internal nodes represent the features of the data set, branches represent the decision rules, each leaf node represents the outcome. So leaf node is nothing but your terminal node. So this is the bookish language, but if you want to put it in your own words, try to put it in your own words. And if you want to get it reviewed, I can review those notes, whatever you have created. But you should understand the concept and you should able to explain it in your own language. That's something you have to work out. Okay. So how does that work? And it is also known as CART algorithm, which is classification and regression trees algorithm. Okay, and it is also called as a greedy algorithm. So we covered this topic. So can anybody tell me why it is called as greedy algorithm? Or did we cover or we haven't covered this topic? Greedy. Okay, and it is also called as recursive partitioning algorithm. So there are various names. Sorry, recursive partitioning. It is also called as heuristic algorithm. So there's various names to it. So why it is called as a greedy algorithm is when it is constructing a tree, it will focus only on this particular node. Okay, it will try to improve the reduce the impurity of this particular node, and it will come up with appropriate decision rules which can reduce the impurity after the split. So here, rather than focusing on the overall accuracy, what this particular algorithm may get, once it gets trained, at every iteration, it is just focusing on the node, on that particular node, rather than focusing on the entire accuracy of the algorithm. That's the reason it is called as greedy. At that point, it is just focusing on that particular task rather than focusing on the overall objective of that particular algorithm. But the process with this process, if it leads to multiple splits and the process by which it construct the tree, eventually it gives the better accuracy. But as you, unlike other algorithm where we have a cost function defined, right? What is a cost function? Cost function will tell me the overall accuracy of the model, how it is performing at a particular point. Okay, so if you are taking a particular weights of the input variables, then what is the overall cost function? That's something we are passing it to gradient descent, and then gradient descent is working in a way that it is optimizing the overall weights of the input variables to reduce the cost function. Here, nothing like that is happening. So here at every step by step, this particular algorithm is focusing on only that particular decision node to reduce the impurity, okay, in the data. How it is, what are the different measures or metrics it basically it uses to calculate the impurity of the nodes, guys? What are those metrics? We talked about entropy, right? Entropy is one. We talked about Gini score. So those are the metrics which we use. And if it is a regression problem, then it is a variance. Please, I would say, please take a note. So these are very important points which I am telling you. So for regression, it 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 uses variance to to calculate the impurity of the node. If it is classification, either you can go with Gini or else you can go with entropy. Okay. Now, you tell me whether this particular decision tree is prone to overfitting or not. Yes or no? At least this you can answer. Is decision tree is prone to overfitting? Just tell me yes or no.
Yes.
Yes. Now the next question is why? See, if you allow this tree to grow itself, so it will make sure that
So
every
if it starts considering all the features,
right,
based on which it takes a decision, then it will be it result into overfitting. So that is why you have to make sure that it is optimized.
right. So see, for every time in the decision node, as I mentioned, it is a greedy algorithm. It will try to improve the impurity. So every at every step, it basically it will tries to improve the impurity so that overall in the terminal node it gets the pure nodes. So in that whole process, it may lead to overfitting because it will learn too much, from the training data set to get the 100% accuracy. But when it is applied on the test data, it may not give you the better accuracy because some of the patterns may not exist in the training data. So instead of uh, allowing this particular tree to grow completely, it's always better, to restrict the tree to certain limit. Okay, and how we can do that? So now comes the hyperparameters. Okay, now we use the hyperparameters to control the size of the tree. And these are the hyperparameters which we use to tune this particular tree models. So what are those hyperparameters? So firstly is the depth of the tree. Okay, the number of features to be used, that could be one of the parameter, or the minimum number of observations in a particular node could be one of the hyperparameter, or the minimum number of observations in the leaf node could be one of the hyperparameters. You can set all those things and you can come up with the optimal values to construct the tree. Now, the second question again comes here is how you can find out the optimal values of these hyperparameters. What are the different techniques for hyperparameter optimization? So we covered that point. You can refer to the code. So there is a grid search optimization and there is a random search optimization, and there is another sophisticated technique known as Bayesian search optimization. But in this course, we have covered grid search, where you can provide certain values, and it will take multiple combinations of all these different hyperparameters, and it will give you the best combination of the parameters, which is giving you the better results. So that's how you can find out the best set of hyperparameters. The another way of optimizing this tree is pruning. Do you remember what is pruning? So pruning is nothing but the cutting, right? So you allow this tree to grow completely and then start pruning, start cutting the branches from the bottom. So on what basis it cuts the branches, guys? So there comes another measure known as information gain. So if there is a significant information gain after the split, it will retain those particular branches. Otherwise, it will go and cut those branches if there is a very minimal information gain through that particular split. In that way, unwanted branches will be removed from the tree, and which will and that's how you can address the overfitting problem. So here it is. Pruning is the process of removing the unwanted branches from the tree. So these are the words, okay, which you have to use. So when you are creating the notes, please bold it out, or highlight it, or underline those kind of words which are important. And see, there's another trick, okay, which you can use. Firstly, create a A4 sheet paper. Okay, if they are 15 algorithms, take 15 A4 sheet papers. Okay, and then very clearly, okay, do not write paragraphs here. Okay, just put one line here, put some space, put another line. So like that, very clearly, and you can be as creative, like by using different colors, or you can mention those sentences which could help you to easily revise that particular topic, and you can even memorize easily. So see, our memory works better if we see something visually rather than reading it. So visual representation of your notes is also important. I've seen people creating the notes, it will be completely messed up. Okay, wherever there is a white space, they'll put something, right, they will write it down. So that messy notes you cannot visualize. Okay, and you cannot remember. If you put like clearly points like this in a complete A4 sheet paper and stick it on your wall, okay, you can, that visual will be there. Okay, that impression will be there in your memory, and you can easily recollect. And then after that, what you can do is, you can just take another, after a while, if you're comfortable with this, again take another A4 sheet paper, just divide it into two, okay, two parts. Now add two algorithms here. Okay, just put KNN here and put decision trees, and just write the keywords, because here you might have highlighted the keywords, right? Just put those keywords here and just put it aside. Put this in front of you, and with these keywords, try to frame the sentences. Whatever you remember from this particular sheet, try to frame those sentences with these keywords. Okay, so in that way, you will become more efficient, or you will be more effective, to respond to those kind of questions. And you can also parallelly create one more sheet from a Python perspective, right? In Python, how this KNN is trained, how decision trees are trained in Python. Again, the key pointers you can maintain here. Okay, and that's how you can quickly revise. And before the interview, these sheets would be very helpful for you. Just you look at it, keywords, remember the keywords, and go for the interview. Okay, so try this. I It worked for me, and I hope it will work for you guys also. Okay, so do not have a notebook kind of a thing where you which is completely filled up with your uh, notes and all. Okay, have a clear A4 sheet papers, and that's the reason you might have seen that in some of the, and this pattern is used for a lot of training programs. For example, if somebody has appeared for CAT exams or any other exam, so they give you a cards, right? If you remember, if you can, if you know about it, so they give you a cards. There would be multiple cards, and each of the cards there would be to remember the vocab. So there would be a word and there would be some picture and then there would be a description. Okay. So why they create those cards is if somebody is not able to remember the text, at least they can remember that visual. Okay, with on that card, and they put it in different colors and all. So it will work. Okay, try this and see that if it is working for you or not. Okay, then again you have two steps. Okay, and you know about steps. Okay, how it work. Okay, so first, it will start with the root node, and then it will go with the attribute selection process, where it will uh, consider either Gini score or entropy or variance based on the problem, okay, what you're solving. And based on that, the attributes will be selected. And then uh, at every node, the different attribute will be selected and the data gets splitted, okay, accordingly. And this process will continue till it reaches or till it finds a pure node, okay, as a leaf node or a terminal node. Okay, so this is Gini index. This is entropy. Variance, you all know. Information gain is nothing but the entropy before and entropy after. As I said, this tree focus would is a greedy algorithm. It always focuses like how to reduce the entropy, in that particular split. So the focus would be more on that. So, so how much reduction in the entropy is done after the split is nothing but called as information gain. Okay, so for pruning, as I mentioned, it will just take it out the unwanted branches from the tree. And you can refer to the code. There we use that cost complexity pruning. So cost complexity pruning is nothing but it will identify what is the overall cost, okay, uh, overall impact on the accuracy if we are removing some unwanted branch. If we are removing and if it is not much impacting on the overall cost or the accuracy, then those kind of branches will be removed. Okay. If you have any questions, feel free to ask now related to that particular algorithm, and get the good understanding. If you're not asking any questions, I'll move on to other algorithm. Okay, now comes the naive Bayes. So naive Bayes, it is it has been it is based on the Bayes theorem, and Bayes theorem we have studied in probability. So it is a probabilistic algorithm. It is also called as Bayesian algorithm. Okay, because here we are using Bayes theorem. So again, it is a supervised learning algorithm, and here this naive Bayes algorithm is purely meant for classification problems only. Here it is not. It cannot be used for regression problem. Here is a difference. Because it is all about probability. So for the regression problem, the probability is not required, right? So there we need a discriminate number, okay, or values. But for classification, the probability works the best, because if we know that what is the probability of this particular observation to belong to a particular category, we can take our decisions better. So here in this particular algorithm, it uses the Bayes theorem to find out the probability. And you know about the Bayes theorem, what it calculates? It calculates the conditional probability. So what is the probability of a particular event to occur given that other events have occurred? Okay. So that's how this works. Okay, and this naive-Bayes algorithm, typically it is considered for text classification, and it has been and it has been considered that for text classification, which is basically high dimensional data, this naive-Bayes algorithm works better on that particular data when compared to other algorithms. Okay, so there are two things people may ask when it comes to naive-Bayes algorithm. Firstly, they may ask you something about the probability. Okay, so it may leads towards some questions around probability. They may ask you what is marginal probability, what is joint probability, what is conditional probability. So okay, so you should be aware of those concepts. And second, they may ask like uh, how it works. Okay, how basically this naive-Bayes works, and then they may also ask you what are the limitation with these algorithms. Okay, so can anybody tell me what is the limitation of this naive-Bayes? So the major limitation is, see, it is considered as naive. So what is naive? So naive means it assumes that all the features which you have considered are independent. The features are not dependent on each other. So if see, when you are talking about conditional probability Bayes theorem, here we assume that the features or the features on which or the events on which my event is dependent, all those events are not kind of depending on each other. For example, if I want to classify the text, okay, as or the feedback as positive or negative. So here we are taking the assumption that whether the particular feedback is positive or negative is dependent on all the words which are existing in your feedback. Okay, all the keywords. So whether it is positive or negative, it depends on all those keywords which are there in the feedback. For example, happy, I'm delighted, I'm excited, I'm satisfied with this particular product and services. So these are the keywords on which the overall sentiment of that particular feedback depends, whether it is positive or negative. But however, in this naive-Bayes, we are not considering what is the dependencies or what is the relationship, the keywords which we are considering as an input variables, they have. So, for example, extremely happy. Okay, so these two words could be related, and these two words may occur most of the times together. But we are not focusing on that dependency, and we are not focusing on that relationship. Okay, so here the major assumption is that all these words are independent, all these input features are independent, and based on that assumption we are going and using this conditional probability, which is nothing but the Bayes theorem. Okay, that's the reason it is called as naive. Okay, this is something, okay, you have to explain. So here naive means it is called naive because it assumes that the occurrence of certain feature is independent of the occurrence of the other features. So features means nothing but the input variables, such as if the fruit is identified as basis of color, shape, and taste. Okay, if let's suppose color, shape, and taste, these are all independent variables, and based on those input features, we have to classify what is that fruit. Okay, then red, spherical, and sweet fruit is recognized as an apple, and hence each feature individually contribute to identify that is an apple without depending on each other. So here, the color, shape, and taste, these three becomes a very important feature based on which we are identifying the fruit. Okay, and we are believing that all these features are contributing for the prediction. And this is something we have already discussed during the linear regression and logistic regression. We talked about multicollinearity. There also there was an assumption that we assume that there is no multicollinearity, which means that there is no relationship, no correlation between the input variables. And why do we need to assume like that? See, if we take a very correlated variables, and the same information, the same insights will be given by multiple variables. Okay, and because of which the training may not happen properly. So we want a very distinct variables, independent variables, which will give altogether different information about that particular event. So here the color is giving us a different information, shape is giving us a different information, and the taste is giving the information. And without one, it would be hard to classify the fruit, right? So each of these variables are important. So that is something we have considered here, and that is how this algorithm is called as naive Bayes. Now this is your Bayes theorem. Nobody will ask you the formula, so no need of putting up the formula or by adding the formula. Okay, so these are the steps. What is the steps? It will take the data set, convert that into frequency table. Based on the frequency table, it generates the likelihood table. And this we have already done, right? The whole practice we have done in the class. Okay, and based on this likelihood, this would be it calculates the posterior probability, which is nothing but your prediction. So here the model is this nothing but this likelihood table. It takes the entire data set and that convert that entire data, training data into this likelihood table. And this is your model for naive Bayes, which is used during the prediction. Okay, so now comes to support vector machines. Can anybody quickly tell me in one or two lines what is support vector machines? Mhm. Okay, so basically support vector machines, as the name suggests, so this algorithm works based on the support vectors. So what are these support vectors? These are the vectors which falls on the boundary of a particular class. Okay, and based on this boundaries, okay, it comes up with it tries to identify the maximum margin hyperplane, which is MMH. Okay, so what is this MMH means it will come up with a separator or a decision boundary which separates the two classes with a proper margin, with a maximum margin. So what is the maximum margin? It is a kind of a white space, or it is the amount of margin which you are allowing on each side or for each of the classes, to handle the noise. Okay, so if there is, or to handle the variance, if there is a little bit variance in these values, okay, still it would be able to classify it correctly. If the margin is less, then there is a high chance that with little variance or with little noise, okay, this particular algorithm may misclassify a particular observation. Then we discussed about different hyperparameters. We talked about kernels. Okay, so there are kernels like linear, polynomial. We have sigmoid. We have RBF. So these are the kernels which would help this algorithm to convert the nonlinear hyperplane to a linear hyperplane. Okay, so this is RBF hyperplane where the data will get transformed by this particular equation, and now with that a nonlinear uh, decision boundary gets converted into a linear form. Okay, so that's how this support vector machine works. And we also discussed about epsilon and the cost function. Now, sometimes uh, there could be some outliers or there could be noise in the data, and if you consider those noise or those outliers, your decision boundary may not be that optimal, right? So for that, you should so this support vector machine has certain hyperparameters through which you can avoid those outliers. So those are epsilon and the cost function. So sometimes, even this support vector machine, while training, it may allow some misclassification to happen, right? And by avoiding those outliers, it may learn better, and it may give you a better results on the training and the test both. Okay, so you can use that epsilon or the cost function, to avoid some kind of overfitting on your data. All right, so that's about support vector machine. But you are seeing that as we are moving from KNN to these complex algorithms, the things are becoming too complicated, right? And even the algorithms are getting complicated. And if the algorithms are getting complicated, that means these algorithms could be, could learn too much from the data, and which may lead to overfitting, and which may lead to high variance. So you have to make sure that for your data set, which of the algorithms may lead to high variance. Okay, and you should avoid using those kind of algorithms. So here, the next algorithm is ANN, and this is based on the human brains. Okay, and it is considered as the fundamental algorithm for deep learning. Okay, so we discussed about how it works. Typically, any ANN has three layers. One is input layer, second is the hidden layer, and third is the output layer. And we discussed how the information flows from layer to layer. Okay, and this hidden layer is the key component of this whole neural networks, because all the patterns or the hidden insights, and even the nonlinear relationships are getting identified in this hidden layers. And this hidden layers has multiple features. It uses transfer functions, it has activation functions, okay, which helps these hidden layers to identify the optimal weights. Okay, and these activation functions will help these hidden nodes, to transform the data into some other form. Okay, and every hidden node will identify a different insights, okay, different pattern from the data, and that collectively will get passed to the output layer, and then the output layer will based on those insights, it will tries to predict the target variable. Okay, and this whole ANN neural networks works to and fro. So the process from left to right is known as feed forward process, while the process from right to left is called as back propagation process. From left to right, the weights gets updated, and the prediction happens in the output layer. And in the output layer, the errors are calculated, or the cost function is calculated. And based on the cost function, again, the weights will get updated, and that whole process is called as backpropagation process. So in the backpropagation process, the gradient descent algorithm works, which update the weights in such a way that it reduces the overall cost function. So this is whole iteration. One iteration of feed forward and the backpropagation is called as epoch. Okay. So how many number of epochs you will consider, then accordingly that many times it will go and update the weights of the network. Okay, so you know about gradient descent, I don't want to repeat again. Yeah, so this is a quick revision I wanted to, because most of the questions may come out of these algorithms, so I wanted to focus more on these algorithms. So if you have any questions, so please come up with your questions. And tomorrow we will discuss on some use cases around LSTM and CNN. Okay. Sorry, if you would have answered my questions, I would have given you more feedback. But whatever best I could give you, I have gave you all that inputs. So please, guys, revise, practice. Otherwise, it would be completely waste of time for you guys later also. Because later, again, if you pick up these topics and start reading from the scratch, again, you have to spend a lot of time. Okay, so Please take out time and create the notes. That's more important. All right, guys, then I will wrap up today's class. Okay, let's connect tomorrow. Thank you.